Okay, this is going to be the video to solve homework problem number 12-35. And this problem says a small surface of area A1, it's going to equals 3 centimeters squared, and it emits radiation as a black body. So I'll jot down that we have a black body. With a total emissive power of 5.67 times 10 to the 4 watts per meter squared. Part of the radiation emitted by the surface area A1 strikes another small surface, A2, which is 8 centimeters squared. Oriented as shown in the figure, which I'll draw out in a minute. Then it says determine the rate at which radiation emitted by A1 strikes A2 and the irradiation on surface A2. So what we're trying to find is the Q dot that goes from 1 and strikes 2. And we're also trying to find in part B the irradiation G that strikes surface 2. Okay. So we have the diagram, we have some surface A1, and we have another surface oriented like such. This is A2. And we're given the angle. So this is the normal from this one, and this is the normal from this surface. We have the distance between the two. That's a little r, and that's equal to 50 centimeters. And then we're given this angle here. This is 40 degrees. And this angle here is 55 degrees. Okay. So we know that the intensity of radiation for a black body is going to equal the emittance divided by pi. So we have that I sub b is equal to 5.67 times 10 to the 4 divided by pi. And that's equal to 1.80 times 10 to the 4. And we know that Q dot from 1 that strikes 2 is going to equal that intensity coming off of 1 times the normal area of 1 times the solid angle omega from 2 to 1. Okay, so first thing, so we're just looking for just this kind of normal area here for A1. And I'll call this area here, this is A N1. Okay. So this is going to equal I1 times that normal area is just going to be the area A1 times the cosine of that angle, 55 degrees. Okay. And then we still need to find out what our solid angle is. So if our surface areas are small, we can approximate the solid angle, omega from 2 to 1. It's just going to approximately be the normal area of area 2 divided by the radius squared. Okay, so this is going to equal A2 times the cosine of 40 degrees divided by r squared, which is equal to 8 centimeters squared times the cosine of 40 degrees divided by our 50 centimeters squared. And then we solve that our solid angle is equal to 2.45 times 10 to the minus 3 steradians. Okay. So now part A, Q dot 1 to 2, right, is just going to equal the intensity times, we had A1 cosine theta 1 times that solid angle from 2 to 1. So we start plugging in our numbers. 1.8 times 10 to the 4 times A1 is, I'm going to put it now into meters squared. So we have 3 times 10 to the minus 4 meters squared is the area times the cosine of 55 degrees and times our solid angle of 2.45 times 10 to the minus 3 steradians. So our Q that's emitted from 1 that strikes 2 is just equal to 7.59 times 10 to the minus 3 watts. And for part B, we're trying to find what our irradiation is, G, and our radiation is equal to Q dot, that goes from 1 to 2, divided by the area A2, which is just equal to 7.59 times 10 to the minus 3 divided by 8 centimeters squared, or 8 times 10 to the minus 4 meters squared. And this is going to equal 9.49 watts per meter squared. And those are your answers.